All right, we're starting a new chapter, chapter 4. And we're going to talk about triangles a lot. Not just in this lesson, but we've done a little bit with triangles before, right? Just a little bit, not too much. But we are going to do a ton of stuff with triangles all throughout the rest of the year. And this is where we basically start, okay? We're going to talk about the angles in a triangle. Well, let's talk about 3 types of angles. We've already discussed this before. This shouldn't be new to you. 3 types of angles. I'm just going to put that for angles. Is that all right? That's the angle symbol. All right. And one. Actually, let's not do that. I think I've shown you this before. Do you know what the symbol for a triangle is? Have I ever shown you that before? I think so. Okay. That's a triangle. All right. So if you draw a triangle like that, it looks like an equilateral, equiangular triangle. That's the symbol for triangle. So instead of writing the word triangle, I just draw a little triangle, and that's what it means. So we got 3 types of triangles, and we describe them by their angles. Okay, so I'm going to put in parentheses angles, because after this, we're going to do 3 types of triangles, and we're going to name them or classify them by the sides of the triangles. But this one, we're going to classify them by their angles. All right. So here we go. So if I draw a triangle that looks like this and like that, all right. So we have a name for this type of triangle. So what do? We look at the angles of the triangle. What kind of angles are all 3 of these angles in this triangle? Like this, just that one angle right there. What would you say it is? Yeah, that's acute. What about this one? That's acute, and that's acute. So all 3 angles, watch, all angles are what? Are acute. If I could write here, are, that looks terrible. Anyway, that's okay. All the angles, all 3 angles are acute. All right, I cannot let that go by. It looks so bad. There we go. Why does that go like that? I don't know. Anyway, all 3 angles are acute. So guess what kind of triangle we call this thing? If all 3 angles are acute, call it a what kind of triangle? An acute triangle. That's right. So this is an acute triangle. All right? We've talked about acute angles before, but now we're going to apply it to a triangle. So if all 3 of these angles, all right, if A, B, this is not writing correctly. I should have restarted my computer. If A, B, and C are all acute angles, then it's called an acute triangle. All right. Now you're probably figuring what this is going to be. What if you had a triangle that looked like this? And I put a little box right here. What does that little box thing mean? It's a right angle. It's a 90-degree angle. Exactly. Okay? So what do you think we call this triangle? It's a right triangle. Now, do all 3 angles have to be right angles? No. How many? 1. And you can only have 1. Think about it. We haven't talked about this, but you probably already know it. If I was to add up all 3 angles, what would they add up to be? 180. 180. Okay? It doesn't matter what kind of triangle it is. Any triangle, if you add up the 3 inside angles, they always add up to what? 180 degrees, okay? So if this is 90, what do the other 2 angles have to be? As far as acute, obtuse, right, all that kind of stuff. These 2 have to be 90? They have to combine to be 90. They got to add up to be 90. But that means, well, they don't have to be 45. They don't have to be exactly the same. You could, this angle looks a little skinnier than this angle right here. So they don't have to both be 45, but they have to be what kind of an angle? An acute angle, okay? So if you have a right triangle, always, every single time, if you have a right triangle, the other 2 angles have to be what? Have to be acute angles, okay? Everybody see that? Because they have to add up to 90. And if you have two angles that add up to 90, that means both of those angles have to be less than 90, yes? So what's an angle that's less than 90? It's an acute angle. So, but we don't call this an acute triangle, even though there's twice as many acute angles as right angles in this triangle. Would you agree? But it is special because it has that right angle. And so what are we going to call this? A right triangle. All right, so that's a right triangle. You can only have one. You can't have more than one. What if you had more than one? Could you even make a triangle out of it? Think about it. Can you have more than one right angle in a triangle? Because look, if that's a right angle, right there, let's make another right angle. There's no way you could get a triangle out. It doesn't matter how far I go up or how short I make it. Could I ever get a triangle out of this? No, because I'd have to connect them, and then it's not a triangle anymore, is it? You with me? So you cannot have a triangle with more than one angle, or one right angle. Okay? So if you have a right triangle, it has exactly, see right here it says all three angles are acute. What do we say here? It has exactly what? One right angle. All right? So a right triangle has exactly one right angle. Denise? You do. Okay. What do you think the next one's going to be? Just take a wild guess. We have acute. We got right. What's the only one we're missing? Obtuse. Okay, so let's do that. All right, there you go. Look at this big angle right there. What kind of angle do you think that is? That's obtuse. That's an obtuse. This thing's dragging terrible. An obtuse angle. All right. So what are the other two angles going to be? Acute. Exactly right. Okay. This has got to be more than 180. I'm sorry, more than 90, right? Between 90 and 180. So these have to add up to something that's less than 90 degrees. And you can only have two acute angles that add up to something less than 90 degrees. Agree with that? All right, so these have to be acute as well. So let's just do that. We'll say that's acute, and this is acute. But what's special about this triangle compared to the other ones? It's a, what kind of a triangle do you think we'll call this? An obtuse triangle, right? This would be an obtuse triangle. And what's an obtuse triangle have? Exactly what? What? One side? You can't have a side that's 90 degrees. Think of what you're saying. You can only have exactly one what? Give me a word. Obtuse. Obtuse angle. Only one obtuse angle, right? We set it up here, right? This had exactly what? One right angle. So an obtuse triangle has what? Exactly one obtuse angle. Everybody good? All right. Let's do another one. I said 3 types of triangles. I'm going to make it 4. All right. Let's do this. I'm going to make, there it is. Let's make it a little bit bigger. Now, I did this on the computer, so all 3 angles. Now, you could call this an acute triangle, couldn't you? Look at it, because all 3 angles are acute angles. Okay, it's pretty obvious that they are. But here's one extra thing that they tell you. It's a pretty big thing that they do tell you. They say they put a little arc here, a little arc here, and a little arc here. What does that mean if they put one arc for all 3 angles? They're all what? They're all equal to each other, okay? They're all equal to each other. So we could call this, watch, an equa, not lateral, because all 3 angles are equal. Equal what? Angular, right? Equiangular. I think we talked about that when we did all those polygon things. Remember that? Remember we said when all the angles are equal and all the sides are equal, what do we call that polygon? We give it a name. No. When both things, when all the angles are equal to each other and all the sides are equal to each other, we call it a blank polygon. A what kind of polygon? Starts with R. I'm asking you. I know what it is. It's regular. It's a regular polygon. You don't remember that? All right. Well, anyway, when all three angles and all three sides are equal, we call it a regular polygon. What if just all three angles are equal? What do we call it? Equiangular. What if all three sides? We're going to do the sides in a minute, but what do we call it if all three sides are equal to each other? We call it lateral, equilateral, okay? You got to know these words, okay? This is like learning another language. You got to study these words. So that's what we have. But right now we have a angular triangle. There we go. Yes. Absolutely. And do we talk about it now? We'll talk about it in a couple minutes, okay? All right. Everybody good with that? So this would be an equiangular triangle if all three angles are equal to each other. But Denise brought up a good point. Can you have an equilateral and an equiangular triangle? Yes, you can. And in fact, this is one. All right, but we're going to talk about that in a minute. Let's go to the sides. Remember we said 3 types of triangles according to their angles. Now we're going to do 3 types of triangles according to its what? Its sides. All right. And we actually did 4, but this will be 3. So 3 types of triangles. This thing's really dragging. I got to write extra slow now. Okay, so 3 types of triangles according to its sides. So I'm not really looking at the angles this time. I'm just looking at the lengths of the sides. Okay? Here's the first one. It's kind of weird. Now, you might look at this and say it's something we've already talked about, but I'm not looking at the angles this time. I'm just looking at the lengths of the sides. All right? I'll just make this up. I don't think this will... Anyway, we'll just make numbers up. Let's say that's 3. Let's say that's 6. And let's say that's 7. Okay? What do you know about all 3 sides? Do they have anything in common? I got a 3, a 6, and a 7. Nope, they're all different lengths, aren't they? All 3 are different lengths. So when none of the sides are equal, right? That's a 3, that's a 6, that's a 7. No sides are equal. Let's put it right here. Or just no equal sides. If none of the sides are equal, we give it a name. It's a crazy name, but we call it scalene. Yes. Can you leave? Where are you going? You got a game. Where you play? Ooh, that's a long way. You gonna win? That wasn't very assuring. Well, if you're gonna win, I'll let you go. But if you're not, you can just stay here. All right. So we call this a scalene triangle. Scalene is just a weird name. It just means none of the sides are equal to each other, okay? So if no sides are equal, we call it scalene. We don't really deal with scalene very often, but it's good to know if none of the sides are equal. So that's one, right? There's 3 of them. That's one of them. Let's do another one. Here's our second type of triangle according to its sides. And I can... All right, so I drew this. Well, I didn't draw, the computer did. I told it what to draw. And watch this. I'll put a little tick mark here, a little tick mark there. What do those 2 little tick marks mean? They're congruent to each other, okay? They're equal to each other. So those 2 sides are equal to each other. Does it look like that third side is equal to those other 2? Does it look like it? No. Okay, it's obviously not. But you can't always go by obviously. All right, just go by the information they give you. So they told you that this side and this side were equal to each other. We have a name for that. So when you have at least, so it's not exactly, but it's at least 2 equal sides on a triangle. Oh, come on. I was trying to write slow, and it's not cooperating. There we go. When you have at least 2 equal sides, we give it a name. You may have heard this name before. Do you remember this? Anybody know how to pronounce that? Isosceles, okay? Have you heard that word before? Yeah, my guess is you probably did. Okay, at some time in your math career, you probably had a teacher that talked about an isosceles triangle. What does that mean, isosceles triangle? It's right in front of you. What does it say? When it's isosceles, it's right there. Just read it so I know that you're paying attention. At least two of the sides are equal, okay? It's right there, okay? If it's an isosceles triangle, at least. That means two or more, all right? And there we go. We got two of them. Usually we save the word isosceles for exactly two equal sides, but technically the definition is at least two equal sides. But most of the time we say, because of what if all three sides were equal to each other? Then we would call it, and that's our next thing actually. So let's just write that down. So what if you had a triangle where you actually had all three sides equal to each other? Again, we're talking about the sides now. Say it, Natalie. That's right. When all three sides are equal to each other, we call it we talked about this earlier, just a minute ago, seems like. We call it equilateral. Okay, lateral means sides. Equa obviously has something to do with being equal. Isaiah, getting all this? Taking good notes, are you? Yeah, it's kind of difficult with your head right down on your desk where you're supposed to be writing. So equilateral, that's all three sides equal. So if I said that this and this and this were equal, we call that an equilateral what? Triangle. It's not hard so far, is it? Nah, pretty easy. Let's go back to the one we did with the angles. It was actually the fourth one. It's kind of like a bonus one. This triangle right here kind of looks like that other one, doesn't it? All right? And it will be. So watch. We're going to learn something a little bit later, but I'll just give you a sneak preview. All right? If you have a triangle and all three sides are equal, that automatically means that all three angles are also going to be equal to each other. Okay? So this triangle right here is not just equilateral, but it's also what? Equiangular. What's true about the triangle when it's both equilateral and equiangular? We just said the word a little bit ago. You guys didn't know it and I had to remind you? What is it? It's a regular, right? This would be considered a regular triangle, okay? But if it's equilateral, it's going to be equiangular. We're going to get more into that a little bit later, but I figured we were here, we might as well mention it, okay? All right, let's do another one. What's going on with you guys today? You seem a little dead. Well, not literally dead, but figuratively. All right, check this out. And I'm going to put a line that goes like this. What I'm going to do is I'm going to do a thing called, it's basically a proof. I'm going to prove something to you. Do you remember I asked you earlier, and you probably already learned this, but if I would ask you why is that true, you'd probably have no idea. You'd probably have no way to show me that this is true. What did I tell you earlier? What did you guys tell me earlier about angles 1, 2, and 3? They add up to 180, exactly right, okay? We have a name for that. Do you know the name for that? When things add up to 180, when they add to be 180 degrees, we say that those angles are supplementary. Did we use that word before? I don't think we did we? Supplementary? We did? Okay. There you go. There it is again. All right. So that's right. We did with the parallel lines cut by transversal thing. Yep. So we did supplementary. So just a reminder for you right there. So look at 4, 2, and 5. What do? They add up to 180. Exactly right. Okay? Everybody with me on that? By the way, that purple one or pink one right here and this one on the bottom, I drew them so they're parallel to each other. That's very important, okay? So I drew that pink line. I made a different color because it's really not part of the triangle. In the book, they might have put a dotted line, or if in your notes, maybe make this dotted. It's not really part of the triangle. It's just a parallel line that hits it at the top of that, right where that vertex is, and it's parallel to this third side. And I'm doing that for a reason. So what did I say about 4, 2, and 5? Angle 4 plus angle 2 plus, come on, next class, I'm restarting this thing, plus angle 5. What do all three of these angles do? They add up to be what? 180. Why? Because they form a, well, not just a line, straight what? Angle. Straight angle. Straight angle is 180 degrees, and those add up to 180 degrees. Yes? Let me do this. Yeah. Tell me something about 1 and 4. What's true about 1 and 4? They're alternate interior angles. And you got parallel lines, so what must be true? What specifically is true about 1 and 4? They are alternate interior angles. No, not if they're alternate interior. What are they? What's that? I can't hear you. No, they're not. They're alternate interior angles. They're not consecutive. They're alternate interior angles. What's true about alternate interior angles? They're equal to each other. Exactly right. Okay. Did you? I didn't hear you say that. You got to speak up. All right. So 1 and 4 are equal to each other. Yes? All right. What else do you see? I gave you a big hint with the 1 and 4. 5 and 3. Very good. Now, it doesn't mean 4 and 5 are equal to each other, so that's got one arc. I'll put 2 here. Okay. Uh-oh. I didn't even... There it goes. All right, it's back on. So 5 and 3 are equal to each other, correct? So check this out. Do you see this angle 4 up here? What do we say it's equal to? Angle 1. So let's replace it with angle 1. You okay with that? All right. Well, it's supposed to be a 1. Angle 1. There you go. Plus, I'm just going to put an angle 2 here because we didn't really do anything with that angle 2. Plus angle 5. What did we say was equal to angle 5? Come on. Angle 3. That's right. Angle 3. So check this out. Put a little degree symbol there. So look what we just showed you. Look what I just showed you. This thing keeps on. All right, I'm not going to touch it. I'll just, well, maybe. Oh, come on, stay on. I don't want to mess it up. All right, it's good now. So check this out. You guys are asleep during a great, great discovery here. This is awesome. Because what did I say before about all the angles inside of a triangle? What do? They add up to be what? 180. Look what I just showed you. I just showed you what? That angle 1 and angle 2 and angle 3 add up to be what? 180. All right? By stuff we already knew how to do, alternate interior angles. I just did a little substitution. Okay? And I just proved to you that all 3 angles inside of that triangle add up to be 180 degrees. I think that's kind of impressive, don't you? I think you're messing with me. I think you're just... All right. Look, this will be better. This will wake you up. Man, the reaction I got last year from one of my classes, I couldn't believe it. I don't think it was sarcastic. I usually can tell sarcasm, but I think that they were truly thought it was cool. Here's another way to do this. Everybody wake up. Samar, wake up. Come on. Shake it off. Shake it off. Everybody look at this. What do I have? I got a piece of paper, and if you're watching this online, you can't see this, but I got a piece of paper, and I cut it into a what? What kind of shape is this? It's a triangle. When do we get out of here? 1:28. Okay, I still got some time. I can do this. This will be the last thing I do, okay, today. We'll finish this tomorrow. So I got this triangle. What I'm going to do is I'm going to rip off one of these corners, okay? It's nothing special, just, and again, this triangle's nothing special. Well, this is a right triangle, actually, but that's okay. I did another one. It's not a right triangle, just to show you it works with that, too. So there's one of my angles. Agreed? I'm going to set it down. Let's take the other angle, this one right here. Okay? There's my other angle. Let's take the third angle. That's this one right here. Now this one happens to be a 90-degree angle, but this doesn't have to be a 90-degree angle for this to work. Okay, I don't want to cut it too small. Everybody with me on that? Yes. So there's my, I just ripped it. So it's not like perfectly straight right here or anything else, okay? But don't know if you can see this or not. So if I took this one, remember, what am I trying to show? I'm trying to show that all three angles of that triangle do what? Add up to 180. And we know 180, watch this. So there's two of them. And then there's three of them. Can you see it? Boom, right there. I put them together. What do they form? A line. They form a straight line, don't they? How many degrees is a straight line? 180 degrees. So what's true about all three of those angles? What do? They add up to be 180 degrees. Isn't that cool? You probably were never shown that, were you? You probably just had your teachers just say, okay, see those three angles? They add up to 180. And that was it, right? That was the end of the story. But you shouldn't put up with that, right? You should say, put your hand up, teacher, right? Why? Why do they add up to 180 degrees, right? And then they would take a piece of paper out, cut it into a triangle, right? Rip off all three angles, put them together, and guess what? It forms a straight line. And a straight line is 180 degrees. This is not a right triangle. Everybody see this? So just having that one to be a right angle doesn't make any difference at all. So let's do it again. There's one angle, there's another one, and there's another one. Do this a little quicker now. Get the idea. So I'm going to put them all together. And if they'll stay, and I'll kind of lift this up so you can see it. See? Those are together, and this is together. And they're different angles, okay? It's a completely different triangle. But if I put them all together, what does it form? It forms a straight line. I don't know if you can see it very well, sorry. But it forms a straight line. So what do all three of these angles, this one, and this one, what do they all do? They add up to 180 degrees because it forms a straight line. You could do that with any triangle, okay? It doesn't matter. I had an acute and a right triangle. I could have made a obtuse triangle and done the same thing, and I would have gotten the same result. So I think that's kind of cool, don't you? That all three angles add up to 180 degrees. And that's why you can say that all three angles in a triangle, any triangle, doesn't matter what shape, right? If I rip this one and this one and this one, then it's going to add up to 180. I don't know, now that I think about it, I might be able to, I don't know, it'll probably take too long. Copy and paste. Oops, let's do this. Copy and paste. Oops, what's that? So I could do this. Maybe it'll take too long, I don't know. Copy and paste. Group it. Okay, there's another one. You see that? So what do you think is going to happen with this angle right here and this angle right here? It should fit in. Copy. Oops, let's group it first, then copy and paste it. Sorry, that projector keeps going in and out. But watch this. See if I can do this. V. Watch that. You see that? And then I could slide that right into there. And check it out. There's my three angles of that triangle right there. They form a what? Straight line. You see it? And so all three of those angles add up to 180. You guys don't seem very impressed. I'm disappointed. I thought you would really enjoy this. Okay? Now, this isn't exact, but you get the idea. I could have twisted a little bit more. All right? So anyway, I think that's kind of cool. I'm a little bummed out that you're not as excited about it as last year's. Last year's geometry class, they thought it was super cool. But anyway, all right. We got a little bit more to do tomorrow, so I'm not going to give you any homework tonight. I'll give it to you tomorrow, all right? And I'll finish up the lesson, probably have time in class to work on it, and I'll assign it tomorrow. Everybody good? All right.